All right, well, I will begin. Sorry I'm a minute or two late. I foolishly decided to use the elevator today. So, yeah. I will begin with a word of prayer. So, Heavenly Father, we thank you for this week and for all your many blessings to us. Help us to make good use of this time to glorify you in what we do. And we just thank you for math and for all your creation that you so graciously created for us to enjoy, Lord. In your name I pray. Amen. All right, so we'll talk a little bit more about factoring. I'll try to be brief here. I just wanted to share another notation for factoring, which was shared to me by another faculty who's not currently teaching algebra, but he loves algebra. And so this is Dr. Sprano's notation. And so let me show it to you here. Suppose we wanted to factor, I don't know, 6x squared plus x minus 35. All right. So this method of notation, what you do is you write down how to get the first and the last number. So 6 is 1 times 6, but it's also 2 times 3, right? 35 is 1 times 35, but it's also what? 5 times 7, all right? Now, so the question then is, how do we use these numbers? Well, basically the idea is to form the, so let me just make a choice. So I think we're going to do is like try pairing 3 with 5 and 2 with 7. All right, so that would mean I do 3x here. Write that like that, yeah? And, okay, so 3 times 5 is 15, right? And 2 times 7 is 14, right? And let me change the color on one of these lines so you can see it better. Yeah? Sorry if you're colorblind. My apologies. I can't really fix that for you, unfortunately. There you go. Now I want a plus, so I think what I want to do is I want to put a plus on this one and a minus on this one, so to speak, right? Because I know that 15 minus 14 is 1, right? And that's what I have here. And so, okay, so we do, let's see here. So the 3 and the 5 are paired. So that makes me put a plus 5 here. All right. And the 2 and the 7 are paired, so that makes me put the 7 over here. Like that. Now you don't have to draw all of the lines I'm drawing, all right, to make this work, and then there's a minus here. Now, listen, whether or not you love this mnemonic or hate it, whatever we think about, the system of notation, we must think through multiplying it out when we're done, right? We need to check our answer. So 2x times 3x is 6x squared. Then we get plus 15 minus 14, which is x, right? And 5 times minus 7 is minus 35. Is that what we want? Yeah. It is. So there you go. The difference between what I'm doing right now and what I did earlier this week is what? What did I not do earlier this week? I didn't always write all the numbers down, right? I didn't write the products. I certainly didn't write the lines. So the difference here is Aw, man. You will not pan the video of that. Oh well. I'm not the first person who's done that. There's like 2. Yeah, oh well. I thought I might be able to reduce the glare. Yeah. I should just get like a giant tarp and pin it up over that window. Anyway. I get tired of looking at the glare of the window. You guys don't see this here because optically it's not there for you. For you, it's in other places. I don't know. But okay, I shut up. Any questions about this? Okay.
So what would you say was different? I got distracted with the...
What? My shenanigans? The prequel to this example, I would have done it this way. 6x squared plus x minus 35. I would have looked at it, I would have said, well, 6 is like 2 times 3, so I'm going to try 2x here, I'm going to try 3x here, and then I know to get 35, I need either 1 times 35 or 5 times 7, and 1 times 35 doesn't look like it, so I'm probably going to try like a plus 5 and a plus 7, and then I think about my life and I go, wait a minute, that's plus 15, and that's, that's plus 15 and plus 14. That doesn't quite work.
What would be plus 7?
Plus 7.
Wouldn't it be minus 7?
Well, yeah, I think I need to do minus 7, right? Well, my point is, my other way, I don't put the right thing down to start with. I write something down that's close to the truth, and then I adjust it until it's what I want. And this method also does that. But the difference is, up here, this is all I write. See, the difference is Dr. Sprano writes these pairs of numbers here and draws these lines between them that are indicative of the foiling of the multiplication that you're going to check. So he writes more. All right? Others of you know this, the box method, so great, whatever. But of course, the answer will be the same if you factor correctly, right? Because the answer is unique up to ordering. I mean, there is this freedom. You got about that much freedom. That's about all you can do. That's the same answer. All right, so anyway, I just wanted to share that with you. That's another way. Now, of course, we could also try like less fancy examples, like something like x squared plus 4x minus 60. Now this one is easier because the coefficient is, the leading coefficient's 1, right? But it's also harder, see, because 60, it's got a lot of factorizations, right? Like this is 1 times 60, it's 2 times 30, it's 3 times 20, it's 4 times 15, it's 5 times 12, it's 6 times 10, it's, is that it?
4 times 15.
I got that one.
Oh, yeah.
And pluses and minuses of all these, yeah? And then over here you've got 1 times 1 for that. That's kind of it. But see, you have many, many choices. But whatever you do, you should get, here I'll draw one. And so if I did, 1 to 60 and 1 to 1, that would be, 61. Like 60 and then 1, that would get plus, that would be 61, right? So maybe I should probably should put a minus on this one, yeah? And if I do that, then I would get a what? I would get a 59. Now that's, my point is you should pick the larger factor should have the plus, the smaller one should have the minus, because I want a plus in the middle, right? So which one of these pairs should I pick? Which one? The bottom one? That one? Yeah, because 10 minus 6 is 4. All right, so how's that work out? In this notation, we do, let's see here. So I said 1 times 6, and so we do plus on this one and a minus on that one. So I do plus 10 and minus 6. I'll change the color to make this less offensive. Whee! There you go. So that's this, right? And that's this. And of course, at the end, we should always multiply it out and make sure it works. X squared plus 4x minus 60. Now, if your ending step is simply to copy this to here, that's not actually an ending step, right? When I say check it, I do actually mean to multiply this times this and see that you get that, right? That step should be done independent of looking back at this. Otherwise, you're not really checking, right? But anyway, let's move on. Any questions, though? No? All right. How about we see if we can. So I'm going to move back into the world of rational expressions and do some more of those. So let's try to see if we can simplify this one. 6 times 7 minus t over 9 plus t times t minus 7. Can you simplify this? So how about this? We pull a minus out of the top factor, right? This is minus 6 times t minus 7, right? Well, that's a good question. I'm not sure how to answer that. How about this? 6 times 7 minus t, right, is equal to 42 minus 6t, right? But that's equal to minus 6 times t. I'll put the t first, yeah? And then how do you get 42 from minus 6? You have to multiply it by minus 7, right? So t minus 7. So factoring is unmultiplying. But just as a generic point of order, if I have something of the pattern a minus b, right? And I want to factor a minus out of it, I just do this, minus b minus a. That's the truth, as I was just using that pattern that I have hardwired into my brain. Pull a minus out, flip the difference. Now, why did I do that? The reason I did that was to make it match the thing in the denominator, right? Yeah, we can cancel them, like so. And what do we got? Minus 6 over 9 plus t. And so the instructions on all of these are to simplify the rational expression and put it in like lowest form or something like that. Yep.
Would you also move the 6 into the denominator and make it positive, or is that like a different scenario?
Oh, we can't. Well, we can't do that. What you're thinking of, I know what you're thinking of. If I had, let's say, 6 to the minus 1 over 7,
right.
Then that is 1 over 6 times 7. That's what you're thinking of. Yeah?
Wouldn't you just be able to rearrange the bottom t minus 7 to 7 minus t to make it match?
Oh, so you see 7 minus, you want to make that into a 7 minus t and cancel that. This you could also do, right? I'll write it out. 6 times 7 minus t over 9 plus t times t minus 7. Francisco? Yeah, Francisco's saying 7 minus t, pull the minus out of this one. Indeed, you could do that. These guys cancel. And then we get 6 over minus parentheses 9 plus t, which is the same as minus 6 over 9 plus t. Yeah, fun fact, if you have a over minus b, that's equal to minus a over b, which is also equal to minus a over b. Minuses are like that. You move them around within reason. Yep.
I'll try a quick question. I figured you can't, but are you able to simplify the 6 and the 9 to 1 and 3, or is it since it's additional to the bottom?
Oh, now that's a good question. Why can't we? All right, let me see if I can think of a similar thing. So suppose I had 6 over, say, 9 plus 1, right? And then I simplified the 6 over 9 and like changed it to 2 over 3 plus 1. Well, then this would be 2/4, right? But this is 6 over 10, which is 0.6, right? Is 0.6 equal to 0.5? So as my community college professor would say, this dog will not hunt. The issue is that you're thinking 6, okay, you're like, here's what your internal logic was this, okay? That's 2 times 3 over 3 times 3 plus 1. You're thinking of canceling these 3's, right? The thing is you cannot do that because you have to have a 3 everywhere downstairs to cancel it. You can't just cancel out of one thing in things added together. This is true either above or below. In order to make a cancellation in a fraction, you have to have that term present everywhere.
So if it was like 9 plus 6?
If you had 9 plus 6, yeah, if we had like 9 plus 6 over 15, sure, we could say that's 3 times 3 plus 2 times 3 over 3 times 5. Then the 3's cancel like that. And we get, 5 over 5, which is 1. Oh, cool. I wasn't planning that. Anyway, let me show a symbolic one like this. Let me erase here. This question has been asked in every section of college algebra. The one you just asked? Every section asks. Example 4. Something like, I don't know, x squared plus 3x cubed divided by, let's say, x squared plus x. Suppose we want to simplify that, right? So there's different ways of thinking about it. One way we can think about it is just try to factor something out of the top and the bottom. All right, so like this is, the most I can factor out of the top is x squared, right? 1 plus 3x. The most I can factor out of the denominator is an x, yeah? So what happens? So the x squared over the x cancels to give me x. So I get x times 1 plus 3x over x plus 1. And that's it. I mean, you could multiply it out in the numerator if you wanted, but that to me is a legit answer right there. Your textbook might want, if your textbook doesn't have a problem like this, as far as I remember, but it might want the answer like that. I really don't care what the textbook wants as an answer, honestly. So, listen, when I ask you on the test, simplify this rational expression, there isn't one right answer. There are several, because it's a question of aesthetics, right? Unless I'm very, very particular in my wording, there's probably not just one right answer. And I try not to be very, very particular in my wording and tests because that tends to confuse students. I try, less is more. So what do you want to show me on a test? You want to show me that you understand algebra, right? Don't cancel the 3, like we were talking about, right? Okay, so example 5. What if we had 30x squared over 2x plus 2, and then we're going to divide by, let's say, x over x squared plus 4x plus, x squared plus 3x plus 2. How do we do this sort of, how do you divide one fraction by another? What do we do? Yeah, flip it upside down to make it multiplication, right? In other words, we multiply by the reciprocal, right? So we got ourselves a 30x squared, and I'm just going to go ahead and factor a 2 out there, yeah? And then I'm going to multiply by the reciprocal of that, which is x squared plus 3x plus 2 divided by x. We all good? Now we can do some things like, 30 over 2, that's 15, right? So we have 15x squared over x plus 1. And x squared plus 3x plus 2, that factors to what? I think that factors to x plus 1 times x plus 2, right? And then, of course, we still have division by x. Now, you can make reductions before you get to the final step, like I already did. I already reduced 30 over 2 to 15, right? In this previous step, I could have canceled the x squared with the x. It'd just leave me an x in the numerator, you know? I could have done that. I just didn't because I'm trying to do more of it in the final step so you guys see it. But, you know. Okay, so, like, again, this piece right here is this one, right? Okay? Just so you're clear. Now, we can cancel. We've got this x plus 1 here. Cancels that x plus 1 there. And this x cancels the square here, right? Because x squared over x is just x. And what are we left with? 15x times x plus 2 divided by nothing. So 1, right? So we could also write that 15x times x plus 2. So yesterday I got home, and my wife made chocolate chip cookies like a week ago, and they're pretty awesome. And I've been eating like a couple a day because I like to eat a couple of cookies a day. Keeps the sadness away. And anyway, my cookies were gone. Now I hid the cookies the day before yesterday. I put them somewhere, and my place of hiding was not sufficiently sophisticated. So the children found the cookies, and then they ate them. So I got home and there's no cookies. And I was sad, because I wanted a cookie. Then my wife made more cookies, which was lovely of her. So I had a couple of cookies, it was great. And then I thought to myself, I need a better hiding place. So what I'm trying today is the freezer, which we're not currently using. We just moved into this house about a couple weeks ago. So we got one of those like extra freezers, and it's just sitting in the kitchen. So I just opened it up and stuck them in there. I'm pretty sure they're not going to figure this out. What do you think? What are the odds they're going to find them? 5, 8, 11, 14, 16. They're going to find it. I did. No, they're not. The freezer's not being used. That's the thing. It's not used. It's not a used.
I'm hungry and open the freezer up. Oh, cookies.
No, they're not going to open it. We're not using that freezer, and they're like they.
Did you hide it in the unused freezer?
Yeah, I hid it in the unused freezer.
Is it in like the basement or something?
No, it's in the kitchen. But I did tell them that I didn't hide them in the basement, so they don't need to look there.
Smart. Safe.
Mm-hmm. So we'll see what happens. If they found it, I'm going to have to up my game.
Just hide under your bed.
I need to build like a a false partition in the wall or something. Let's see here. For some reason, my wife usually stops me from like cutting holes in walls. I don't know. I cut a hole in the wall once and it was really hard to fix, and I keep hearing about that every time I want to cut another hole. But in my defense, that house had wallboard that was like this thick. Built in the 50s, they used to use this gypsum board that was like an inch thick. It's crazy. Okay, so moving on. Let's work another. Now, I personally detest this notation I just used here. This is not my happy notation. Let's try a different one. Suppose we have like 1 over x plus 1 minus 3 over x, all divided by 1 over x. There's a problem kind of like this in the homework. Sure. Now, here's the neat thing about this one, is division by 1 over x is the same as multiplication by x. So when I multiply by the reciprocal of this, I just get x. Bless you. So then what? Then you multiply, right? Distribute. X over x plus 1 is what it is. This marker's strong. Then the x's here cancel, and we're just left with minus 3. That's a legit answer on my test, unless I word it, leave your answer as a fraction, in which case, you can do a little bit better.
Wait, why did the x not get distributed to the...
It did. You want me to write another step? X times minus 3 over x, so these x's be canceling. You'll forgive my grammar. I put another, sorry. Listen, let me just leave the minus out here. This is more natural for me. Like that, okay, yeah. Now, we want to leave our answer as a fraction, right? So to make that a common denominator, we got to take that 3 and multiply it by x plus 1 over x plus 1, which is allowed because that's just multiplying by 1, right? So this gives me x minus 3 times x plus 1 divided by x plus 1. Now let's clean things up, right? We have to distribute that minus 3 through. We get x minus 3x minus 3 divided by x plus 1. One more step here. That is minus 2x minus 3 divided by x plus 1. We have to distribute the minus through. If you guys are getting that problem wrong, high chance you're not distributing the minus. Did I make my 3 become a 2? Yeah, I should warn you, I showed up for the first class today in the wrong room. So, generally speaking, trust what I say, but verify. Yeah.
Multiplying the 3 by the x plus 1 over x plus 1. How are you able to...
Oh, you talked, yes, it was a minus 2 because it was x minus 3, which is minus 2. Sorry. This is one of the bad things, is like I get in this cycle of doubt, and I'm very gullible today. You could probably talk me into many things, so please don't take advantage of me. Yes, questions?
Oh, I was saying, so you multiply the 3 by the x plus 1 over x plus 1. Where did you pull in the x plus 1?
Oh, so the idea here is when I add fractions, like here, example 7.
Yeah, you have the same denominator.
Exactly. So if I want to say 1 over x plus 2, minus 3 over x plus 4, how would I do it? The way I think about it is I do, 1 over x plus 2 times x plus 4 over x plus 4 minus 3 over x plus 4 x plus 2 over x plus 2. So I multiply each fraction by whatever I need to make the denominator the same, but I'm always just multiplying by 1. This is equivalent to like just cross multiplying. See, because like in the end, we have the same thing you get from the cross multiplication thing, which is x plus 4 minus 3 times x plus 2 divided by x plus 2 times x plus 4, right? So like, but when I just have, one of my things is just a 3, I don't need to cross multiply really, right? I just need to make this one become a fraction, and multiplying by 1 is how I do that.
Well,
Yeah.
I guess since it's like working with something where you don't have something on the other side of the equal sign, you don't have to, I guess, copy what it is you do to one side.
Now you may be thinking about solving equations,
yeah,
which we'll get to, but right now we're manipulating expressions. So like when we're manipulating an expression, all we got to work with essentially is like adding 0, factoring things out, or multiplying by 1. When we're manipulating equations, then we can do things like like move from one denominator to the left side to the numerator to the right side, and we've got all those other things. But yeah.
When you distributed the x in the beginning, did you only do it to the numerators?
Are we talking about
Example 6, sorry.
example 6?
Yeah, at the top in purple.
So remember, if I have, this is a fraction over a fraction, right? So I'm multiplying the numerator by the reciprocal of the denominator, right? The thing is, the reciprocal of 1 over x is x.
Yeah, when you distributed that out, does it only go to the numerators?
Yes.
Okay.
Yeah, okay, fine. I gotcha. So if I've got x times a over b plus c over d, that is equal to x times a over b plus x times c over d. How do we multiply fractions? We multiply by the numerator. I gotcha. I understand what you're asking. That's, yep. So to clean up example 7 here, we've got, minus 3, so I got a minus 2x, and 4 minus 6 is minus 2, and then I guess I can do a little bit better. Minus 2 times x plus 1 over x plus 2 times x plus 4. That would be my final answer. The stupid thing logs itself out. Like, it takes so little for it to log itself out. I changed the power setting so it's not supposed to fall asleep, but it's still, it has the attention span of my 5-year-old. All right.
Can you do a slightly more complicated version of these? Not by 1x, but
Yeah. So example 8. We could run up against something like x plus 6 over x minus 2 over x minus 1 divided by x over x minus 1 plus 1 over x. Something like this, yeah? So call this example 8. And so something like this, yeah, we're not going to get out of jail so easily this time. We're not just going to multiply by x, right? Because the denominator is not so simple. But essentially the idea I would use is to multiply by something which clears out all the denominators. So you could do this in 2 steps. I'm just going to do it in 1. So the question is, what should I multiply by in order to clear out all those denominators? I would say x over x is a start, but I also want what? I also want an x minus 1 and an x minus 1. See, if I multiply by this, we'll clear out all the denominators, right? So I'll write it out here. So this is x plus 6 over x times x minus 1 minus 2 over x minus 1 times x minus 1. That's the numerator. The denominator, x over x minus 1 times x minus 1 plus 1 over x minus 1. I don't usually even write this step out, guys. I usually think through this step and go straight to the one I'm about to write in purple. So the x's cancel. So the first thing gives me just x plus 6 times x minus 1. And then I have minus 2. The x minus 1's cancel that one, and I'm just left with minus 2x there. Downstairs, this x minus 1 and the x minus 1 cancel on the first summand. And I got x times x, which is x squared, yeah? Okay, and then here the x's are canceling, and I'm just left with plus x minus 1. And then, of course, you can simplify the numerator here, x squared plus 6x minus x minus 6 minus 2x. It's FOILed it out. So what we got? We've got x squared plus 3x minus 6 over x squared plus x minus 1.
Would you be able to show what canceled?
So these guys canceled. This canceled with that and that one. This one canceled with that and that one. And this one canceled with that and that one. Now you could go through in 2 steps, right? You could first multiply by x over x. That would get rid of the 1 over x fractions, right? And then you could go back and in a second step multiply by the x minus 1. Then you get rid of the 1 over x minus 1 fractions. But I just did it both at once. It would be kind of like my numerical example earlier, multiplying by 15. I could have multiplied by 3 over 3 and then multiplied by 5 over 5, but actually I'm not sure if I'm remembering that example right. Shut up. All right, so let's move on here. So that brings us to linear equations. Now you're like, you haven't left yourself much time for linear equations. That's true, because you guys need much, much more help with these than you do with the linear equations. The linear equations, if I never said boo about them, you'd still be able to solve them more than likely. But let's solve a few, mostly for the sake of introducing terminology. Let's see here, 3x minus 2 equals to x plus 18. All right, we'll solve that one. Then we're going to solve something like 3x plus 1 equals to 3x plus 8. Solve that one. And then we're going to solve, let's see here, 2 2x plus 7 equals to 2x plus 7. All right, so we're going to solve these 3 problems to start with here. All right, let's start on the first one. What do? What's the goal? Your goal is now to find the number which makes the equation true, right? Up till now, have we been doing that? No. We've been manipulating expressions, right? Factoring and simplification. There's no answer which is a number, right? The answer is itself a formula. These are conceptually very different problems. Now, the laws of algebra apply to both discussions, but they are really different problems. So we're trying to solve this. So I think what we should do, we could subtract x from both sides, and we could add 2 to both sides. If I do that, that gives me 2x. The x's cancel over here, and we get 20. So x is equal to? 10. Very good. So the solution here is 10. The solution set is the set containing 10. It's a very silly solution set, but there it is. How about this next one? What happens?
Do we have to write that weird sol 2 set on the...
I mean, you can write solution out if you don't want to write my solution abbreviation.
Oh, well, like, do we have to do that, or can we just do actually?
The textbook asks you for solution sets in places in the homeworks. I'm talking about it. Oh, no, like on my test, if I ask for the solution set for the problem, and then like it's 10 with the, in the curly brackets, but you just write x equals 10, yeah, I'm gonna like take off all the credit.
You will take off?
No, of course not. I want people to pass this class. So that would I'd just be a jerk move for me to do that. If you write x equals 10, I know you've understood the problem pretty well. Technically, that's not the solution set. The set containing 10 is a set. The number 10 is a number. There's a difference between a number and a number in a set. But this isn't like something I feel like people should have to retake the course for, or even lose more than like 10% of credit on the problem for. The fact remains your homework does talk about solution sets, so that's why I'm talking about it. Okay? Now it's more interesting in example 11. Let's do example 10 though. So what we subtract 3x from both sides, what do you get? You get 1 equals to 8. No, right? This is a contradiction. This is an absurdity. So what this means is that there is no solution. Or the solution set is what? It is the empty set. It's the set which contains nothing. All right? Example 11, we subtract 2x and 7 from both sides. What happens? 0 equals 0. Is this true? Indeed, it is true. So what's the solution set this time? It's not just 0. People don't say that, just 0. But no, it is minus infinity to infinity. It's all real numbers, assuming we're working in a context of real numbers. Right? So example 11, 2x plus 7 equals 2x plus 7, is a rather silly example of what's called an identity. An identity is something that's true independent of the variables. If you'll allow me to extend well past the borders of this course for a moment, but probably something you saw in high school. You remember this? Cosine squared theta plus sine squared theta equals to 1. You're like, no. This right here is an interesting identity. That is true no matter what angle theta you pick. It's true independent of theta, right? So example 11 and example 9 are example of consistent equations. Example 9 and example 11. Identity, that's just example 11. That's an identity. Inconsistent, that's your example 10. All right. So the last 10 problems in your homework, they're all linear equations. I think I should do 2 more for you guys before we stop today. Example 12. Just a labor-saving comment for you. if you have 0.2x minus 0.4 equals to, say, 0.1x plus 6, how would you solve such a thing? Multiply by 10 is a very helpful suggestion, yes. Why? Because we hate fractions, right? Well, we hate decimals. So multiply by 10. 0.2 times 10 is 2. 0.4 times 10 is 4. 0.1 times 10 is 1. 6 times 10 is 60. And now we have a problem which doesn't look so ugly, right? So solve this. I could subtract x from both sides, add 4. The x's, they be canceling over here. We get x equals to 64. Huh, well, that's funny. What's the solution set? The set containing 64. Is this consistent or inconsistent? Consistent. I should also mention that these two were conditional. Why were they conditional? Oh, excuse me. Which one of these is not conditional? They're not both conditional, are they? Example 9 was the conditional one. The condition is x equals 10. This equation is only true if the condition x equals 10 is met. All right. And finally, let me work one more for you guys. And this is the kind of problem that actually matters for physics. Some of you might be in here because you need to take Physics 201. And I think this is a prerequisite for that, isn't it? Yeah. So if you had something like, I don't know, C is equal to 1/4, let's say, I don't know, B times S plus, oh, I don't know, K. All right, so example 13. And then you're supposed to solve for S. How do you, so this is a little bit different than the last few problems I did, right? Now we have more variables, right? You got your C, you got your B, you got your S, you got your K. So the answer here is going to be in terms of letters. It's not just going to be a number. It's not an identity. Anyway, so what I would do, I would start by doing, now here we get back to, who was asking me about multiplying things to the other side? See, this is where we do that, right? So now we multiply the 4 over there, we get 4C is equal to B times S plus K, which gives me 4C is BS plus BK. Isolate the S, so subtract BK to the other side. I'm going to do it this way. BS is equal to 4C minus BK. So I put this over here, and I flip the, I turn the equation over if you don't, I know it's confusing if you don't see what I did. And then what? Divide by B. So S is equal to 4C minus BK over B. If we have time, I'll do another one. If we don't, I'll stop here. Oh, I was out of time 2 minutes ago. My bad. So can you hit stop? It's the button. You see it?